Hello students, we are going to see another unit, that is networking and internet devices, and along with that we will also discuss the various routing algorithms. Starting with your topic, first we will see that. Okay, let us start. So we have networking and networking devices. First, we must understand what are the way. What do you mean by actually networking devices and internet networking devices? So first, if we talk about the all type of networking and networking devices are called basically connecting devices because these are the devices with the help of which you are connecting various components. So we have some networking devices and we have some internetworking devices. So by networking devices, we mean that the devices which are used within a single network. Okay. To connect the subcomponents of a single network, we use networking devices, and to connect one network to other network, we call it basically as internetworking devices. So let us start with the first networking device, that is your repeaters. And you can see in this diagram you have 7 layers of OSI model. The repeater works on the first layer, basically physical layer. Bridge works on the data link layer. Router works on the network layer. This you have to remember. And gateway works on the application layer. Now we need to understand one thing here. If you are talking about that router works on the network layer, that means router works on all 3 layers, all first 3 layers. And if you talk about bridge works on the second layer, data link layer, that means it works on the first 2 layers. And as we can see, gateway works on the 7th layer, that is application layer. That means it works on all 7 layers. Okay, so you can have a question like anybody may be asking you may ask you the simple question like router works on which layer, or bridge works on which layer, or gateway works on which layer. So let us start with the introduction of the first device, that is repeater. As we have seen, this is a device works on the first layer, that is your physical layer. And we all know we have a bad parameter in the transmission, that is attenuation, the loss of energy when the signal travels because of the resistance offered by the wire. So signal weakens basically. So repeater is a device which can regenerate a signal for me, because I told you we cannot use amplifier here for amplifying my signal, amplifying the strength of the signal, because amplifier also increases the strength of the noise. So we cannot use amplifier to increase the strength of the signal. We have to use a device called repeater. So between the two network segments, I have to use a repeater. I will send a signal from here to that segment. So in that case, a repeater will be regenerating a signal for me. It will be increasing the strength of the signal so that signal should not die out. The function of the repeater. So you are having some corrupted signal, and or maybe signal which is dying. It can convert you a regenerated signal for you. Similarly, we have a second device of the chapter, that is your bridge. Bridge works on the second layer. As I told you, it works on the second layer. That means it works on both first layers, that is physical layer and data link layer. The basic purpose of bridge is to connect the segments of the network. Like we have one segment of the network and we have the second segment of the network. So basically, to connect the different subnetworks to form a single network, we use a device called bridge. And we have to see some concept here, like ABCD computers are on one side of bridge, one section of the bridge, and EFGH computers are on the other section of the bridge. So if A wants to send data to C, so in that case data does not need to cross the bridge because they are on the same side of the network. But suppose A is sending some data to G, in that case bridge is going to play its role, because bridge knows that G is not within this network. So it has to cross the bridge to reach the G. That means bridge has basically a table in which the bridge records basically that which computer is lying in which subnetwork. That is how bridge is able to make that data deliverable. Like say when two computers are on the same network, in that case the data does not need to cross the bridge. But suppose that computer is on other side, in that case data needs to cross the bridge to reach that computer. Now we have a multi-port bridge also. Like we have simple bridge where you will connect two subnetworks. But if you want to connect more than two subnetworks, 1, 2, 3, so there we call it a multi-port bridge. The purpose is same. Like bridge knows like ABC computers are here, DEF computers are here, GHK computers are here. So bridge has information of all the those computers attached in the different networks. And suppose you remove this computer, this information will be updated to bridge that this computer is not working now. So bridge is basically an intelligent device. It works on the second layer of. Third layer we have seen is it is a router device, works on the third layer, that is your network layer. That means it works on all first three layers. So router basically, as the name is saying, router or router, you can say it, which finds the route because you have multiple networks you can see. So a router is a device which you can use for connecting one network to the other network. And the basic idea of router is to find the shortest path, of course. And shortly we are going to see the various routing techniques. And a router is a device basically which needs to find the shortest path from any source to any destination computer. So next device we have is the gateway device. It works on all 7 layers. That we also call it like it works on the application layer. That means it works on all 7 layers. And you can see here now you need to understand like what is the difference between a router and the gateway. A router is basically we are attaching when you are connecting to networks of the homogeneous type, but a gateway is a device that you attach when you are connecting heterogeneous type of network. Like suppose and that is why we also call a gateway as the protocol translator. So because see, on this side we have a different technology network, on this side we have different technology network. So when a packet of SNA network enters the network, so network will not understand because both networks architecture are different. And when network packet will enter SNA network will not be able to identify it. So gateway plays its role here. So gateway we use when we connect heterogeneous type of network. So it will take a packet from SNA, convert it to gateway, will convert that packet to NetWare understandable form, and will take a packet from NetWare and convert it to SNA's understandable form. So gateway is a device basically we use for when we are connecting heterogeneous type of network. Now we have single protocol routers and multiple protocol routers also. Like routers working on the single protocol or working on the multiple protocols. Similarly, we have another device called Brouter. Brouter is a combination of bridge and router, so it can play the role of both. It can work as a bridge also, it can work as a router also. Now switch, we know we have talked about when we connect computers using switch or when we connect computing using hub. Hub basically broadcasts the signal, switch basically unicasts the signal. Switch is a better version of hub. And generally in all your labs you are having those switches through which all the computers are connected to each other. So next topic we have is the routing algorithms for it. We have discussed those devices. Routing algorithm is basically an algorithm which will decide basically that incoming traffic should be following which path. So which path the packet should go, the routing algorithm has to decide. So we have 5 type of techniques: is adaptive routing, non-adaptive routing, distance vector routing, link state routing, and shortest path routing. So what are the good properties of a routing algorithm? It must be correct, that packet must be delivered to the correct destination. It should be simple, faster. It should be robust. Robust means suppose there is some malfunctioning in the network, the router should be able to handle that failure. The stability, there are some conditions in which router has to handle some situations like there is a packet drop. There's a big packet drop ratio, so router has to handle those conditions. Then it should be fair and optimal. Like optimal, of course, any algorithm you will not use for which is giving you bad effects of it. So you will, of course, if we talk about like you are trying to find the shortest path, so optimal. That is my principle of optimality in that case. That the routing algorithm should generate best results for me. That is optimality. Now we have non-adaptive routing and adaptive routing. Non-adaptive routing basically they are not based on their routing decisions, because see they cannot adapt to it. Like suppose there are some problems, and you can see here all the decisions are made in advance and it is offline. And this is also something called static routing, because in this case the router is not able to adapt. The packet has to go from the same path. But in case of adaptive routing, you can see they can change their routing decisions to reflect changes in the topology. Suppose some computer is down over there, some computer is not working, and then routing adaptive algorithms can change their route. They can change their path because data must be delivered to the receiver side. Then we have distance vector routing. We are going to see with the diagram. Routing, distance vector routing basically has the knowledge about the whole network, and I will show you one diagram for it. It has knowledge about the all computers in the network, and but it will share its routing information only with the neighbors of it. Like see, you see the diagram. We have a network, but this A has got neighbors E, F and B, F and E. So router has knowledge about the whole network, but it will share this knowledge only with the neighbors. A's neighbors are B, F, B's neighbors are A and C, F's neighbors are A and C. Sorry, only A in that case. But third property is routing information will be updated on regular interval of time after a time slot. Suppose as I say 5 seconds. So after each 5 seconds, the routing information will be updated. Suppose B stops working here. Suppose B stops working here. So this information will be updated after an interval of time. So this is the routing table basically. Distance vector routing table. If you use distance vector routing, so this table is used: network ID, network's address, cost of it. Cost means basically the effort it will be taken by the data to reach the another side of it, and next computer basically on the network. And link state routing is just the reverse of distance vector routing. In that case, we were having knowledge about the whole network, but we were sharing only with the neighbors. Here it is reverse. We are having information only about the neighbors, but we will share with all on the network. Third difference, we had routing information will be updated at regular interval of time, after each regular interval of time. But in case of link state routing, the routing information will be updated when there is a change. When there is a change means suppose you add some computer onto the network, or you remove some computer from the network. That is the change basically. But here the routing information will not be updated after like distance vector routing after each 5 seconds. Here we will only update routing information when there will be a change. Like change is basically when you add some computer or you remove any computer. So this is the diagram for it. Like you can see here, a link state routing. I send information about my neighbors to all router. So it has information about the neighbor, but it will send to all, which is the just exact reverse of your distance vector routing. This is the link state packet of it. Like advertiser is basically who is advertising that computer on the network. The network address, the host, cost of it. The cost is basically of traveling that packet, and the neighbor of it, the neighbor computers of it. And another routing I told you, that is your shortest path routing. It is basically you have studied already that Warshall shortest path finding in case of data structures. Similarly is the case of Digit algorithm we use for it for finding the shortest path routing. So these are all routing techniques we had. Thank you.